Hi, and welcome to this part 7 of our V-block project video. Now, we have been looking at the blocks themselves, but we mustn't forget that there's another part involved here, and that is the clamp, and that's what we're going to be looking at today. Now, if we look at the drawing of the clamp, we see that the dimensions are quite bizarre. I mean, you would expect it to be 2 inches wide by 1 inch high by a ½ inch thick, because I can get one by a ½ inch stock quite readily, and that would save me a lot of work. But you have to remember that this was a school project, and part of my objective as the ornery old teacher, well, was to make the students work for it, because the objective here is to learn. Now, if I gave the students a 1 by ½ inch piece of stock and said, see, you don't have to cut anything, well, they wouldn't be learning very much. So that's why those dimensions are bizarre. Actually, it's what, 900 thou high by 400 thou thick. So we have some to take off there. But the width is bizarre because it has to be. The block is about 2 inches wide. Well, it is 2 inches wide. And if the clamp was 2 inches wide, well, when we laid the block over on its side and I was holding a part in it with the clamp, that clamp could come and interfere with the block's positioning, because the clamp could rest up on the surface plate. And I don't want that. And that's why the width or the length of the part, depending on how you're looking at it, but if we look at the drawing, we're talking of the width of the part is 1 inch 980 thousandths. So that's 20 thousandths smaller than the block, and that means that when it's assembled in the block and I put the block sideways, the clamp won't skew the positioning of the accurate block. So all this starts with cutting some stock to length. So let's head over to the cut-off bandsaw and cut off our parts. There, we have 1, 2, and 3 blocks with our first surface milled. Now, what next? Well, I'm going to bring this down to the 0.9 inches that it's supposed to be, and then bring its thickness down to 0.4 inches and its length down to 1 inch 980. And I'll do that for all 3 blocks because we're producing 3 clamps. I won't be leaving any extra material on here because these clamps aren't hardened, so whatever finish I get here plus a little hand finishing is what I'm going to end up with. So no extra material left on. Now, we have already seen squaring up blocks several times in different videos. Amongst others, well, we have a video dedicated to that, so squaring up blocks, here's the title. And we also have a video where we looked at it quickly. The video is the 1, 2, 3 block project. And more recently, well, we've done the tap block project where we used this very mill here to square up 10 little tap blocks. So go take a look at those if you want to learn more about squaring up. What we're going to do is we'll jump ahead. I'm going to motor through these operations and we'll jump ahead to the point where we're going to be drilling the holes and milling the angles on these parts, because that's something that will be done in a way that we haven't looked at in other videos. And there's our 3 parts, nicely squared up and to their final dimensions. Now, we still have some layout work to do, some drilling to do, and some cutting and milling. So cutting on the bandsaw and milling. So let's start with drilling the holes. And now I'm going to bolt together these two 1, 2, 3 blocks to form a very simple fixture. And with that positioned on the table with this auto-locking clamp, well, I'm going to be able to position all my holes with that one basic setup. So let's bolt these together and get this set up. There. Now, in the original setup, I'd left enough room here, and this is important, to be able to swap this center drill for my drill proper without moving the table, and that will keep everything positioned as it was. And I'll be able to continue using the same setup. Now, I got away with that. What I mean is just holding it there with my fingers, because the fixture counteracted all the forces in play here. So there was no danger. And even the chisel end of the drill, well, kept a force, a down force, that would stop the part from pulling up. So no auto penetration here. But that would have been very different had these holes gone through the part, and that's important to note. If the holes had gone through, I would have had to clamp my parts, because as the drill would exit the bottom of the hole, it would want to thread the part up onto the drill, and that's very dangerous. So these holes aren't through holes. That's why I purposely set my depth stop so I can do it that way. Now I can hear the comments. I've said in other videos that you shouldn't flip-flop your parts. We measured from one end and then from the other to position those holes. And I got away with that because the outside dimensions of these blocks that I finished on the mill are quite accurate. They're all within 1/1000th of an inch of what's indicated on the print. And that means that since the positioning tolerance of those holes is ±5, well, I can get away with flip-flopping because I know the dimensions of each block and I know that they're the same and quite accurate. Now we want to lay out our contour lines because we have some flats and some angles to produce here. And for that, well, I've applied a thin coat of layout blue. We're going to start by laying out a line at 400,000ths of an inch from the surface with the two holes, very important. And then, I'm going to do that on all three parts, and then I'm going to lay out two lines. One vertically at 400,000ths of an inch, and a second one just after that at 540. And I'll do that only once on one block, and we'll use that block to set up our angles. Those lines that I've scribed, the two last ones, well, they're going to indicate intersections for the angular cuts. And now we can head over to the bandsaw. So I have my part all cut in the bandsaw, and normally I wouldn't have done that because notching the top, fine, but cutting out this bottom profile, well, that gives me a problem. I have nothing left to lean up on to position the top for that notched V-cut. Well, I still have the top, but it's difficult to position on that one. Not the end of the world, but a little more difficult. So why did I cut these? Because normally I would have notched that on the bandsaw and completed the top V before even thinking about starting the bottom cutouts. But I don't have a proper bandsaw in my shop. So that means that I went outside to do the bandsaw work, and I wasn't going to do 2 or 3 trips. So I bandsawed the whole thing out at once, and I'll work around the problem. What I'm going to do, I'm going to use my vernier protractor on the top of the part to set it in the vise with the bottom of the notch just barely clearing the top of the vise jaw, and I'm going to mill it in that position. I'm going to mill the bottom and the side in the same setup. And I'll do the same for all 3 parts. So let's take a look at that. So I've flipped my part over and I'm ready to do the small flat on this end. Now I've positioned the part flush with the end of the fixed jaw, and that way I can turn the part, reinstall the second end of flush, and take another cut. Once I'm set for this first cut, well, I won't have to move the machine again. I'll be set for all my cuts, so I'll lock everything down and then just come and cut all 6 flats one after the other. One point of contact for my tertiary surface, 2 points of contact along the parallel here for my secondary surface, and 3 points of contact on this angle plate. And I have a nice little jig that uses isostatics to position my part for milling this surface. And since all my other parts, sides of this part and my other parts are identical, well, I'll be able to use the same setup to mill all the 6 angular surfaces. Well, a little hand finishing, and there you go. We have 3 clamps for our 3 V-blocks. In our next video, that's going to be the last of this series, we're going to be looking at the heat treatment and the finishing of our V-blocks. So until then, have fun, be safe, and happy machining.
There you go.